variables and expressions. One of the most important things in any lesson is you can't understand it until you understand the vocabulary. What do those words mean that we're working with? So the first vocabulary word we're going to talk about is variable. Okay, what is a variable? In mathematics, what's a variable? Jossie?
A letter or symbol used to represent a value that can change.
Okay, a letter or symbol. We're going to say typically it's just a letter. So let's just say, the book might say or symbol. A letter used to represent. Start there. A letter used to represent, and I expect you to be engaged in note taking. This is not optional. You need to be doing it. Okay? And we say a value that can change. So a letter used to represent a value that can change. Another way I like to think of it is a letter that is used to represent something that's unknown. So it's kind of like standing in there temporarily. Now, how can that value change? Well, if we use the letter x used in one expression might be equal to 10. Used in another expression, it might be equal to 1/2. We have to, the letter x is not always going to be, in other words, the same number. The letter A is not always going to represent the same number. It kind of reminds me of the story of a student that said, here's the reason I couldn't understand algebra. I always thought that A was equal to 1 because it's the first letter of the alphabet. B was equal to 2 because it's the second letter of the alphabet. And C was equal to 3 because it was the third letter, and so on. And Z would be equal to what then? 26, because there's 26 letters in the alphabet, so Z would be equal to 26. And they said that's why I could never figure it out, because then the teacher would come and she'd say, no, the answer for this problem, it isn't A equals 1, it's A equals 3.5. But how's that possible? A is not the third and a half letter of the alphabet. So the value, it can change. It isn't just one set value that variable is representing. It depends on the problem. So a common, very common one, I just used it, x, examples. We're always going to give ourselves visuals. X is a visual of a variable. Give me another visual of a variable. Y. That's another one really commonly used. Think back to your prior math experience. What's another one commonly used?
H.
H. What's one that was just used in what we just did? N. Okay. Now, so those are just some examples. How many different variables could there actually be? 26, because the whole alphabet, right? Yeah. But the crazy thing is sometimes they even use them as capital letters instead of small letters, so then there's like another 26, and so variables, we can really have lots of choices. Okay, what we do want to stay away from some letters, like when you get to pick your own variable to use. If you use the letter O, what does it look like? 0. If you use the stick L, what does it look like? 1. If you use the stick T, what does it look like? Plus sign, yeah. So here's one of the things you do typically when you write variables, try and get in this habit. Write them in cursive. Don't print them, write them in cursive. Do you still know how to do cursive? Yes, awesome. We still know cursive. Okay. Constant. What's the definition for a constant? Conte. A value that never changes. Awesome. A value that does not change. Some days I just write so big. Okay, a value that does not change. In other words, if your parents say they're going to give you $15, $15 is going to spend the same way anywhere, because $15 only has one value. They can give it to you in all ones, they can give it to you in 3 5s, they can give it to you as a 10 and a 5, but it still only equals what? 15. It still only equals $15. It's not if they give you 3 5s, that's not going to buy you more than 15 ones would. So it's going to be equal amounts. So give me an example of a constant. I just gave you one. 15, thank you very much. Okay, 15 would be an example of one. Give me another one. A constant. 20. Okay, let's get more creative.
53.
Let's get more creative.
45.
Let's get more
1
creative.
million.
You're all giving me natural numbers.
1 plus 2.
No.
100.135 cents.
Okay, so 100, what was it?
35 cents.
$100.35, so 100.35, is that a constant? Sure is. How about this, is this a constant?
Yes.
Is 1/4 always going to be the same value?
1
Yes.
half.
How about this guy? What's that?
Yes. 3.1415.
Pi, yeah, it's the same all the time, even though it's we don't know what it exactly equals because it's one of those irrational numbers. It's still pi is still pi. There's no different flavors even. Okay, so a constant, a value that does not change. Okay, numerical expression is another vocabulary in this lesson. Boy, this is really important that we first of all understand this. Would you plant this in your brain first? Expressions never have an equal sign. Would you repeat that? Expressions never have an equal sign. No matter what. If you hear the word expression in mathematics, there better not be an equal sign in your expression. So if I say to you for 100 points, put your name at the top of your paper and write down a numerical expression for me, you better be able to do it. You put an equal sign in it, you're done. Because there's no equal signs in expressions. So we're going to say a numerical expression is a mathematical phrase. And the reason we say phrase is because it's like English. It's part of a sentence, but not a whole sentence. So it needs no punctuation, it needs no capitalization, it's a mathematical phrase, so it doesn't even really have words. It's a mathematical phrase, it doesn't have an equal sign into it. Think of a sentence like this. A sentence is like an equation. A sentence is like an equation. A sentence has a full thought, a capital letter at the beginning, a punctuation at the end. An equation is a full thought, it's got an equal sign in it.
What is the difference? The sentences don't have equal signs.
They don't have equal signs, but I'm telling you how they are alike, not how they are different. How are they alike? They have a full thought, capitalized punctuation, equation, equal sign, saying whatever's on that side is the same as what's on that side, a full thought. Expressions never have what?
Equal signs.
Equal sign. So a numerical expression, our mathematical phrase cannot have an equal sign, but that's not what we're going to put. We're going to put that contains only constants and or operations. That's right. So in other words, we're saying it doesn't have to have an operation. Okay? A mathematical phrase that contains only constants and or operations. Well, we know what a constant is. We have a visual of it right above this one. Anybody know what the operations are in math? What's one operation, Julia? Multiplication. What's another operation called? Subtraction. Aurora, what's another operation? Division. And what's another operation? Pardon? Addition. And Noah? No, we already said subtraction. In other words, how many operations are there? There's only 4. The other 4 of you would have not been able to get one without repeating it like Noah did. Like he said, I'll just try this again. I'll say subtraction again. There's only 4 operations. So we know what a constant is, we know what an operation is, so we should now be able to write a numerical expression. So let's write some examples of numerical expressions. Give me one. 40.
2n plus 1.
Oh, what's in there that 2n plus 1, what disqualifies that to be a numerical expression, you guys?
It's an operation.
No, it can have addition. Well, no, it can't have an equal sign. We don't want it to if it doesn't. And the n. You can't have that n in there. Does it say it can be variables? No. So can we write 2 plus 1? Yeah, 2 plus 1 is a numerical expression. But not 2n plus 1. Devontae?
B2
18 minus 4.
18 take away 4. Okay, let's get more creative. Noah?
4 times 16.
4 times 16, and I'm going to use the multiplication dot. We're now in algebra where x means a variable, and you get confused with the multiplication. So does it have to have an operation?
No.
No. So Cody?
Pi times
Oh.
3 squared.
Pi. How about just pi? No operation. Is pi a numerical expression? Yes. Pi is a numerical expression. And then I heard that times 3 squared. Would 3 squared be a numerical expression? Sure is. Doesn't have a variable in it, does it? In fact, there's a hidden operation in 3 squared. What is the hidden operation in 3 squared?
Square root.
No. Remember, operations, there's only 4 of them. What's the hidden operation in 3 squared?
Division.
No. What does 3 squared mean?
Multiplication.
Multiplication means take 3 times itself.
2 times.
Yeah, so there's 3 times 3 is what it really means. So that's just a shortcut way of writing 3 times 3. Something times itself. Okay, algebraic expression then. Okay, well we know an expression doesn't have what? An equal sign. Algebraic, oh my gosh, that almost makes my brain say right away. Algebra, there's those things called variables. So what do you think an algebraic expression has to have in it? A variable, yeah. A mathematical expression, so let's do, or phrase I mean, a mathematical phrase that contains variables, and we can just say variable slash s because it doesn't have to have more than one variable, it can just have one variable in it. So a mathematical phrase that contains a variable or variables and or, what do you suppose it can also have in it?
Mutual natural numbers.
It can have natural numbers, but what should we call those natural numbers? What's the term for a natural, what term did we use today? Okay, operations it can have, but a natural number is also a
Constants.
constant. So we can have constants, so we're going to say and or. So constants and operations. So it has to have a variable. It has to have at least one variable. It can have constants with it. It can have operations with it. And of course, no equal sign or it's no longer an expression. So give me an example of an algebraic expression that's just hanging out there on your visual map.
2n.
Give me one, Jesse. Give me one, Aurora. 4 minus n. Thank you, Jesse. 4 minus n. That is an algebraic expression. Give me one, Demonte.
14.2 times x.
14.2 x or times x. And another way that they maybe would show this one is they might put the x in parentheses so you know that you can see that 14.2 easier. Okay, that means 14.2 times x. Cody,
The exertion.
pardon?
The exertion.
No. Okay, how much is the letter y? Would that be an algebraic expression? Does it have to have an operation? Does it have to have a constant? Does it have to have more than one variable? Oh, then couldn't y just be it? Couldn't I just use the letter y and say that's an algebraic expression? Okay. So, and we can also do it so it has more than one. How about if we have the expression x over y? What does that tell us? What's x over y mean? Division, x divided by y. So, you know, yeah, what can't it have? An equal sign. What does it have to have? A variable, or an algebraic expression. Okay, so you need to make sure you understand these words. And you can put a visual. When I say the word algebraic expression, you're like, oh, I know what she's talking talking about the toppings on our pizza for lunch today. She's talking about a mathematical phrase that does not have an equal sign in it. That's just a given. You say that in your brain all the time. It doesn't have an equal sign in it, but it has to have a variable. And you can picture one. That's how you're going to help yourself be successful if you can do those things. Okay, the next topic we're going to cover are words for mathematical operations. What kind of words indicate to us addition? When you see this word, you're like, oh, I gotta add more. Okay, so but we're also going to put it in a, like kind of like a phrase. Would we say 4 more 5, or would we say 4 more than 5, and then we would know we should add, right? So we're going to use the words more than. We can use more than one word, okay? More than. If I say I have $6 more than you do, more than, you're going to add 6 to whatever amount of money you have. You'll know what we have, how much money I have. Okay? How about another word for addition? You're going to be like, I got to add these babies.
I have 3 more pop bottles than you do.
That's kind of like the same thing, using the same words. Some. Oh, spelled how? S-U-M. S-U-M. If you see the word the sum of, you know that something got added together. Okay? Give me some more addition words. Monty?
Added
Added to. 3 added to 4. Tell you, well, that's use the operation addition. I mean, there's lots of them for addition. I know you can more than this. Don't think too hard. There's some really basic ones that you're like, you've been using since first grade. How many you do those? Abby? Plus, yeah. 10 plus 10. We know what we have to do. Okay, give me another one. And it can be, remember, it can be a group of words. It doesn't have to be just one word. That will help you out. That will help you out. Give me some more words that we put in our notes. Increased by. You guys are learning how to use your resources already. Increased by. Are there any others? Abby? Put together. Are you getting a picture of, like some words that you could use? You can add to this list. There's more probably hanging out there somewhere, but we've got a good start to a list of some numbers that mean addition. Let's go on to the subtraction. Subtraction.
less than.
Less than, okay? So, 4 less than 7. What is 4 less than 7?
3 negative.
This is subtraction is tricky because does 4 take away 7 mean the same as 7 take away 4?
No.
No. So when we use the words less than, we have to be really careful. 4 less than 7 means I'm supposed to take 4 away from 7. What would it be?
3.
3. Okay, so those are good words for subtraction. Give me another word or words for subtraction.
Subtract this.
Okay, I heard minus.
Difference.
Difference. Difference means the result you get when you do a subtraction problem. The difference of. And again, that's a really tricky one. You have to say it carefully. The difference of 7 and 4 means 7 minus 4. The difference of 4 and 7 means 4 minus 7. So we have to be, subtraction is tricky. We have to be more careful with subtraction. What's another?
Subtraction.
I think I heard subtract. Okay, so do we say 4 subtract 5? Do we say that? Does that make sense? Yes, we can. Subtract. We can just use the word subtract. Do we use the word subtracted by? Do we say 7 subtracted by 4? We can. then we know it goes in that order. 7 minus 4. 7 subtracted by 4. It's kind of a silly way. We don't necessarily hear it that way very often. What if I want to show that the 4, what if I say it this way? If I say 7 subtracted by 4, I know that is 3. What if I say 7 subtracted from 4? Now what's the order? 7 subtracted from. Oh, then it's 4 minus 7. 7 is being subtracted from that 4. So we have to be really careful with subtraction, okay? Don't think, you know what, I can just throw down anything. I have to think through the process for subtraction. Okay, let's go to the back side, multiplication. Maybe some words for multiplication. Times. Oh yeah, that one's been around forever. Times tables. You knew you were multiplying then. Of. Okay, in a word problem, of means, but we don't typically say this, 4 of 6. And know that means to multiply. So we have to be careful with just using the word of. Aurora? Product. We know that if they tell us that they're giving us a product, some multiplication happened. Abby? Equal groups of. Or just equal groups. Okay.
Multiples.
Not multiples, but again, we don't say 4 multiplied by. That's another way we could do it. Multiplied by. By the way, is multiplication fussy? Is that one of those tricky ones too? Is 2 times 3 different than 3 times 2? No, we don't love multiplication because it's like addition, it's not so fussy. That darn subtraction will make you just have trouble. Okay, how about division? Quotient. This one's kind of a harder one to come up with some for. Quotient.
Divided by.
Divided by. Abby? Yeah, separated into equal groups. Is division fussy? Is 10 divided by 5 the same as 5 divided by 10?
Yes.
Okay, so I have $5. I'm going to divide it among 10 people. How much money are they each going to get? I have $5. I love to use money because money is just so popular.
50 cents each.
If I have $5 and there's 10 people, I'm going to give them equal amounts of money. They're each going to get 50 cents, right? So 5 divided by 10 is a half of $1, isn't it? 50 cents, 1/2. Okay, now I have $10 and I'm going to split it into 5 equal for 5 people. 10 divided by 5. How much is every person going to get? $2. Huh, is that the same? Is getting 50 cents from me the same as getting $2 from me? No. So division is fussy too. It's like subtraction. Hey, you better be careful of me. You don't get to say it haphazardly because you got to make sure people understand what they're supposed to do. 10 divided by 5 doesn't mean the same thing as 5 divided by 10. So we have to be careful with division. Okay, now we're going to move on to, you need to be on page 6. In your books, if you're not there. We're going to translate, we're going from algebra to words. So we're going to start with going from symbols to words. So from our algebraic symbols, which is algebra, to words. Okay? And there's an example problem there that you can kind of use as a cheat sheet for you while we're trying to work these. We're going to do the check it out problems on the bottom of that page, below check it out. Or called the check it out below the example problem. So 1A. I'm going to write down what 1A looks like, and then we're going to write that in words. So here's how it starts, and you should put it down also. Here's how it starts. That's what's that called again? That's an algebraic expression. Good job. It's an algebraic expression. We're going to write that as a word phrase. So somebody give me a way we could write that as a word phrase, Aurora?
4 minus
4 minus n, there's 1. And we have to, that is the exact order we have to put it in. We could not say that n minus 4 is the same thing, because subtraction doesn't let us do that. What's another word phrase we could put? Devante? 4 taken away from n? Do you all agree with that? Is 4 being taken away from n? Or is n being taken away from 4? The n is being, so we're going to have to change that up. N taken away from 4. We have to be careful with subtractions. It's such a pain. We have to be careful. I'm so glad you did that, Devante, to make a point for us. Okay, there's lots of ways we could write this. We had to write 2. Okay, the next one is this, t fraction bar 5. So we have t fraction bar 5. T divided by 5, that's one way we could write it in words. And no abbreviating here, you don't use the division symbol, we're writing a word phrase. The only thing I don't make you write out is the number as a word. I let you off the book there. T divided by 5. Give me another one.
T. 5 plus
Devante? 5 separated into t groups
It's
is 5. If we did it that way, 5 separated into t groups. Let's pretend t is 2. 5 separated into 2 groups. What would there be in each group? 2.5. What if we said it the other way? T separated into 5 groups. And 2 now would be separated into 5 groups. Would there be 1/2 in each of those groups? 2 of something is separated into 5 groups. Would there be a half of something in each of them? Or 2.5, I mean? So we gotta be careful here. So how are we gonna say this? Let's think about this. How do we say it? Is it t separated into 5 equal groups? Or is it 5 separated into t equal groups?
T separated.
It's t separated into 5 equal groups. We have to be careful with division, just like we do with subtraction. Okay? The next one, we have that 9, and an addition sign, and a cube. 9, addition sign, cube. Which of course is said, typically, what? 9 plus cube. Well, that's a given one. Let's be more creative. Let's come up with a couple others. Let's not do 9 plus cube. We're bigger than that.
9 more than 2.
9 more than
Q.
q. Okay? How about 9 more than q? In other words, 9 is supposed to get added to q. Could we have written it this way? Q more than 9.
No. Yes.
Is 9 plus q the same as q plus 9?
Yes.
Yep. So when we write the word phrases for addition, it doesn't matter who's first. It doesn't matter who's first. Okay, give me another one. Julia? Sum of 9 and we don't use the plus sign there. The sum tells us we're going to use the plus. Sum of 9 and q. You guys are good. Okay. And the very last one that we have is 1D, and it's got that 3, and then it's got parentheses, and then it's got an H. 3 parentheses
3
H.
times H.
3 times H. Okay, there's a good start. That's what that means. 3 times H. Noah? Give me another one. Calvin, help him out. Abby? Yeah, 3 multiplied by h works. 3 multiplied by h. We're writing words, you don't get to shortcut it and write the mathematical symbols. No, we're using word phrases, okay? So 3 times h, 3 multiplied by h. Could these have been this way? H times 3? Is 3 times 2 the same as 2 times 3? So could it have been h multiplied by 3? Absolutely. Order does not matter in multiplication or addition. They're friendlier. Okay, they're much friendlier. Okay, what I'm going to expect you to do for me is I'm going to expect you to do number 2 on your own. I want you to finish along with the homework you have to. I want you to finish up these notes. How are you going to do number 2 on your own? What's the first thing you should do to do this? Go to example number 2. Where is example number 2 in your book? Page 7. Read through that example, and then you're going to do the check it out problem underneath it. And where can you check to see how you did? In the back of the book. We did that yesterday. Remember, we found out where we can do that. Okay, so.
The number 2 would be like 2A, right?
So yeah, we need 2A.
Just that one.
Yeah. Well, is there just a 2A?
Three of them.
No, there's 2A, B, C.